So last month, I was consulting for a financial services company that had just completed their AWS Direct Connect setup. They had a beautiful 10 gigabit dedicated connection to their ES East 1 VPC. Everything was working perfectly, and then the CTO asked a simple question. Can we also connect our EU West 1 VPC through this same circuit? The room went silent because they had just realized they'd need to provision an entirely new Direct Connect circuit in Europe, costing them another $100,000 annually.
Ouch. I'm guessing there was a better way to handle that?
Exactly. If they had implemented a Direct Connect gateway from the start, they could have connected up to 10 VPCs across any AWS region through that single physical connection. That oversight cost them 6 months of re-architecting and significant budget overruns.
Okay, that definitely got my attention. I've been working with basic VPCs, and even set up a site-to-site VPN, but Direct Connect Gateway sounds like a whole different level.
Welcome back to Cloudcast, everyone. I'm your network ninja, and today we're diving deep into AWS Direct Connect Gateway and multi-region VPC connectivity patterns. My guest today is our favorite curious developer who's ready to level up from VPN connections to enterprise-grade hybrid networking. By the end of this episode, you'll understand exactly when and how to use Direct Connect Gateway to connect your on-premises data centers to multiple VPCs across AWS regions.
I'm excited for this one. But let's start at the beginning. I know Direct Connect is AWS's dedicated network connection service, but what exactly is a Direct Connect Gateway, and why can't I just connect my Direct Connect circuit directly to multiple VPCs?
Great foundational question. Let me paint a picture. Imagine Direct Connect as a private highway you've built between your corporate headquarters and an AWS region. Without a Direct Connect gateway, that highway has exactly one exit ramp, leading to one VPC in one region. If you want to reach a VPC in another region, you'd need to build an entirely separate highway.
So the Direct Connect Gateway is like adding an interchange that lets my single highway connect to multiple exit ramps?
Precisely, and that analogy holds up well technically. The Direct Connect Gateway is a globally available resource, not tied to any specific region, that acts as a hub. Your physical Direct Connect connection terminates at a virtual interface, which connects to the Direct Connect Gateway, and then that gateway can associate with up to 10 virtual private gateways or up to 6 transit gateways across any AWS regions worldwide.
Wait, you mentioned virtual private gateways and transit gateways. What's the difference in this context?
This is crucial. A virtual private gateway, or VGW, attaches to a single VPC. So if you associate your Direct Connect gateway with 10 VGWs, you're connecting to 10 individual VPCs. A transit gateway, on the other hand, can connect to thousands of VPCs within its region. So associating with 6 transit gateways could theoretically give you access to thousands of VPCs across 6 regions.
So the architecture choice depends on scale. Small deployments might use VGW associations, but enterprise deployments would go transit gateway.
Exactly right. And here's a technical detail that catches people. When you create a Direct Connect gateway, you must specify an Amazon-side ASN, which is the autonomous system number used for BGP peering. AWS allows you to use values in the private ASN range of 64,512 to 65,534 for 16-bit, or 4,200,000,000 to 4,294,967,294 for 32-bit private ASNs. This ASN must be different from your on-premises ASN. If you don't specify one, AWS defaults to 64,512. I'd recommend checking the current AWS documentation since there can be specific restrictions on certain ASN values.
BGP keeps coming up in networking conversations. Can you explain how BGP works specifically with Direct Connect Gateway?
Absolutely. BGP, Border Gateway Protocol, defined in RFC 4271, is how your on-premises router and AWS exchange routing information. Think of it like 2 postal services agreeing on which zip codes each one handles. Your router advertises your on-premises CIDR blocks, say 10.0.0.0 out of 8, and AWS advertises the CIDR blocks of your associated VPCs, maybe 172.16.0.0 out of 16 for one VPC and 172.17.0.0 out of 16 for another.
So if I have VPCs in US East 1 and EU West 1 both associated with my Direct Connect Gateway, my on-premises router would receive BGP advertisements for both VPC CIDR ranges?
Correct. Your router's BGP table would show routes to both 172.16.0.0 out of 16 and 172.17.0.0 out of 16. both reachable via the Direct Connect Gateway. The traffic flows from your data center, across your Direct Connect circuit, through the Direct Connect Gateway, and then AWS's backbone network routes it to the appropriate region. This is important. The inter-region traffic travels over AWS's private backbone, not the public internet.
That's really elegant. But I'm wondering about the actual setup. What does the configuration look like in the AWS console?
Let me walk you through the components, and this is where it gets important to understand the two different patterns. In the AWS console, you navigate to the Direct Connect service. First, you create the Direct Connect Gateway itself, specifying a name and your Amazon side ASN. Then you create a virtual interface on your Direct Connect connection, and here's the key distinction. The type of virtual interface depends on what you're associating with.
What do you mean by different types?
There are three types of virtual interfaces. A public VF is for accessing AWS public services. A private VF can connect directly to a single VGW for simple single VPC setups, or it can connect to a Direct Connect gateway that then associates with multiple VGWs across regions. A transit VF connects to a Direct Connect gateway that associates specifically with transit gateways. This distinction is critical for your architecture.
So if I'm using virtual private gateways for my VPCs, I use a private VF with a Direct Connect gateway. But if I'm using transit gateways, I need a transit VF?
Exactly right. That's the key architectural decision. Private VFs with Direct Connect Gateway give you the VGW path, supporting up to 10 VGWs across regions. Transit VFs with Direct Connect Gateway give you the Transit Gateway path, supporting up to 6 transit gateways across regions. You can't mix them on the same virtual interface.
That makes sense. So the old way of doing things was a private VF directly to a single VGW, limited to one VPC in one region. The new way is private VF to Direct Connect Gateway to multiple VGWs, or transit VF to Direct Connect Gateway to transit gateways for even larger scale.
You've got it. Now let's talk about a critical architectural consideration: allowed prefixes. When you create a gateway association between your Direct Connect gateway and a VGW or transit gateway, you can specify allowed prefixes. This controls which CIDR blocks are advertised to your on-premises network.
Why would I want to limit what's advertised? Wouldn't I want full connectivity?
Security and routing table management. Imagine you have a VPC with CIDR 172.16.0.0 out of 16, but it contains a sensitive subnet at 172.16.100.0 out of 24 that should never be reachable from on-premises. By configuring allowed prefixes to only include 172.16.0.0 out of 24 through 172.16.99.0 out of 24, you prevent that sensitive subnet from being advertised. Also, on-premises routers have BGP table limits, so advertising only necessary prefixes keeps things manageable.
That makes sense. What about the reverse direction? Can I control what my on-premises network advertises to AWS?
Yes, and this is where a common and serious mistake happens. You control outbound advertisements from your on-premises router using BGP route policies or prefix lists. However, AWS has a hard limit. You can only advertise up to 100 prefixes per BGP session to AWS by default. Here's the critical part. If you exceed this limit, AWS doesn't just stop accepting new routes. It terminates the entire BGP session, which causes complete connectivity loss until you reduce your prefix count.
That sounds catastrophic. I've seen companies with way more than 100 internal routes.
Exactly why this catches people off guard. Route summarization is essential. Instead of advertising 50 individual/24 networks, you summarize them into a single/19 or aggregate them appropriately. This requires careful IP address planning, which is why enterprises often use contiguous CIDR blocks for AWS destined traffic. For organizations that genuinely need more prefixes, you can contact AWS support to request a limit increase for certain use cases.
Let's talk about a real scenario. Say I'm a company with a data center in Virginia, and I need to connect to VPCs in US East 1, US West 2, and EU West 1. Walk me through the architecture.
Perfect example. First, you'd establish a Direct Connect connection at an AWS Direct Connect location near Virginia, like Equinix DC2 in Ashburn. You'd provision either a dedicated connection of 1, 10, or 100 gigabits per second, noting that 100 gigabits per second is only available at select locations, or use a partner for a hosted connection at smaller capacities. Next, you create your Direct Connect gateway with an ASN, let's say 65,001. Your on-premises router uses a different ASN, perhaps 65,000.
And then I create the virtual interface?
Right. Now, let's say you're going with the VGW approach for this scenario since you have 3 VPCs. You create a private VIF on your Direct Connect connection, specifying your on-premises ASN of 65,000, the Direct Connect Gateway, and VLAN tagging information. You'll also configure BGP peering addresses. You can either let AWS auto-generate addresses from the 169.254.0.0 out of 16 link local range, or specify your own peer IPs within certain constraints.
Then I associate the Direct Connect Gateway with my VPC's gateways?
Exactly. For each region, you'd have a virtual private gateway attached to your VPC. You create a gateway association between your Direct Connect gateway and each VGW, specifying allowed prefixes. For us East 1, maybe you allow 172.16.0.0 out of 16. For us West 2, you allow 172.17.0.0 out of 16. For EU West 1, you allow 172.18.0.0 out of 16.
And my on-premises router would then see BGP routes to all 3 of those CIDR blocks?
Correct. Your BGP table would show all 3 prefixes reachable via the Direct Connect connection. When a server in your data center needs to reach an EC2 instance at 172.17.50.10 in US West 2, the packet goes across Direct Connect, through the Direct Connect gateway, across AWS's backbone to US West 2, and into the VPC.
What if I had a larger deployment with hundreds of VPCs? Would I use transit gateways instead?
Exactly. In that case, you'd create a transit VIF instead of a private VIF, connected to your Direct Connect gateway, and then associate the Direct Connect gateway with transit gateways in each region. Each transit gateway can connect to thousands of VPCs within its region, giving you massive scale. The transit VF setup is slightly different. AWS allocates /29 CIDR blocks from 169.254.0.0 out of 16 for the BGP peering on transit VIFs.
What about latency? If my Direct Connect terminates in Virginia but I'm reaching EU West 1, that's a long path.
You've hit on an important consideration. The traffic does traverse AWS's global backbone, which is optimized but still subject to physics. Virginia to Ireland is about 70 to 80 milliseconds round trip. For latency-sensitive applications, you might want Direct Connect locations in multiple geographic areas. AWS also offers Direct Connect Site Link, which allows traffic between Direct Connect locations without going through a VPC, but that's a more advanced topic.
Before we wrap up, what's the biggest mistake you see people make with Direct Connect Gateway?
Overlapping CIDR blocks. I cannot stress this enough. If your US East 1 VPC uses 10.0.0.0 out of 16, and your US West 2 VPC also uses 10.0.0.0 out of 16, you cannot associate both with the same Direct Connect gateway. BGP cannot distinguish between them. The AWS console will actually prevent this association, but I've seen teams waste weeks designing architectures only to discover this limitation at implementation time.
So IP address planning across all VPCs needs to happen before any Direct Connect Gateway work begins.
Absolutely. And document it meticulously. The second common mistake is forgetting that Direct Connect Gateway doesn't enable VPC to VPC communication. Traffic from your US East 1 VPC cannot reach your US West 2 VPC through the Direct Connect Gateway. It only enables on-premises to VPC connectivity. For VPC to VPC, you need VPC peering or transit gateway peering.
That's a subtle but critical distinction. So to summarize what we've learned, Direct Connect Gateway is a global resource that acts as a hub between your Direct Connect circuit and multiple VPCs across regions. It uses BGP for dynamic routing, supports up to 10 VGW associations or 6 transit gateway associations, and requires careful CIDR planning to avoid overlaps.
Perfect summary. I'd add 3 key takeaways. First, understand the virtual interface types. Use private VFs with Direct Connect Gateway for VGW associations, and transit VFs with Direct Connect Gateway for transit gateway associations. The choice depends on your scale and architecture, not just whether you're multi-region. Second, plan your ASN strategy and CIDR blocks before implementation. Third, remember the 100 prefix default limit for BGP advertisements. Know that exceeding it kills your BGP session entirely, and use route summarization. The AWS Direct Connect documentation and the Direct Connect Gateway section specifically are excellent resources for the detailed configuration steps, and always verify current limits since AWS updates these periodically.
This has been incredibly helpful. I finally understand why that financial services company's architecture needed such significant rework.
And that's exactly why we do this show. Learn from others' expensive mistakes. Thanks for joining us on Cloudcast, everyone. Until next time, keep your roots summarized and your CIDRs non-overlapping.